Good morning. I want to do a video on how to plan a Versah guide, and the particular case that I have selected is this site tooth number 4 here. This is going to be in Blue Sky. Blue Sky Plan is a free software that you can evaluate CT scans, you can plan cases, you can create surgical guides. Just a world of opportunities that you can do with Blue Sky Plan. And I would encourage most every dentist to get involved with learning Blue Sky and being able to treat your patients better. Versah is a specialty set of burrs that are designed to expand bone and condense bone rather than cut bone. And so they're very, very good, very effective for bumps, vertical sinus lifts, and also ridge expansion. So there's a lot more you can learn about Versah at versah.com or with the Versah company. They teach courses on this, how to use their burrs. But what I'm going to focus on is how do you plan a guide, because it's a little different than the traditional guides that we make using keyed systems and whatnot, or even non-keyed systems, because it's a little different thinking, different way of thinking when you're talking about a Versah guide. So you can see here I've already got a STL file, and this patient is planning to have an implant placed at tooth number 4. Now there's a little bit of a fluid level in the sinus. Obviously you want to check out that kind of pathology, but we've been cleared on that from his ENT. But we're going to put an implant at the tooth number 4 site and design it for a vertical augmentation. Okay, so I've got an STL file that's been properly aligned. You can see with the hint lines that it meets and matches up with the patient's anatomy very well here. And if I kind of click all around this, you'll see it aligns very, very well. So once you have an STL file, a clean optical scan of the patient's dentition aligned with the patient's anatomy, you are ready to plan your implant cases. This is the most important and the most tricky part about Blue Sky. Although it has some automated features, some cases with heavy restorations don't align all that well automatically, but there are techniques that you can use to make that happen. But this is the STL that's been aligned to the patient's anatomy, and we're ready to plan an implant. So we're literally just going to go drop an implant into the space, and I personally use BioHorizons, so that's what I'm going to stick with in this case. I'm familiar with this case. I planned it and did it with a 4210, so let me find the right family and load that in. And so you just really click in here and you drop the implant into the space, and then you begin to manipulate it to align it to the way that you want it to be in the surgical guide. If I go ahead, I like to add a little custom abutment here just to give me an idea of where I'm headed. Usually make the length pretty long. And then here it is in the plan, and I can manipulate the angle of emergence to where I want it. In the tangential, I can rotate around this implant in 360 degrees and get it positioned in the bone the way that I would like for it to be. Look at it prosthetically. maybe I'd like to tip that back just a little bit to the lingual, the emergence. That's starting to look pretty good. You just keep manipulating it till you get it exactly the way you want it. And I think I would be happy with that at approximately that position. Let me check the adjacent teeth. I look like I'm far away from any of the adjacent teeth structures. I'm barely bumping into the sinus, not very much. Let me see, right there, that's a little close in that angle. So I might bring that back just a little bit, check it prosthetically. And I can accept that. You can play with these however you might want to. If I move, because I now have a straight abutment that will allow me to do a screw symmetrical type of restoration. Double checking all the way around the implant to make sure that I'm where I need to be. Okay. That looks good. That looks good. I think it looks good prosthetically. I think it looks good between the adjacent teeth. I would be happy with that implant in that position. And you can see we're just very slightly bumping into the sinus. So let's see how we're going to design a surgical guide. So when you're designing a surgical guide, we'll take a quick look at these little warning markers. The warning markers telling us a drill kit warning. That essentially means that wants us to make sure we have the correct drill kit selected. I'm okay with that, so I'm going to acknowledge it and make it go away. Okay, so now we have no warnings on this implant. That just means that if you wanted parallel implants, the angles are correct. In this case, that doesn't apply. If you were putting two implants side by side, it would warn you if they were closer than 3 millimeters to each other. If you had a nerve involved, it would warn you if you were within 2 millimeters of the nerve. Okay, so having taken care of all the warnings, I'm now ready to design the guide, and I've got the implant in the right position. I'm ready to design the surgical guide. To design the surgical guide, you essentially set the parameters for this surgical guide tube. And if you've got the custom kit, the complete guided kit selected for your particular implant system, it will automatically set these. But we're going to do this with Versah, and so we're going to change these parameters to fit the Versah guide sleeves. So this is a 4.2 millimeter diameter implant. So I have a cheat sheet, if you will. This is the Versah guided system, how to size the sleeves, and we're going to insert one of these C sleeves into our guide. And you see that this medium sleeve will accommodate an implant up to 4.3 millimeters in diameter, and this C sleeve has an outer diameter of 6.1. Okay, outer diameter of 6.1. The stop position, the vertical gauge, or the G-stop, slides into the C-sleeve, and it stops right down here at the bottom. This leading edge will touch the bottom of this C-guide, and it's exactly 1 millimeter off the bottom of the C-guide. All right, so these are the concepts you have to use when you're designing the surgical guide that you're going to print to accommodate this C-sleeve, which will then allow you to control your stop position. So the outer diameter of this C-guide is 6.1 millimeters. So if I come back over to Blue Sky and I set the outer diameter, the guide hole outer diameter, if the outer diameter of the sleeve is 6.1, the hole in your guide has to be slightly larger in order to accommodate the sleeve. And I just know with my Form 3 printer, that is approximately 0.2 millimeters. So instead of 6.1, I will put in 6.3 for the guide hole diameter. That's the hole that will be made into the guide that will accommodate the C-sleeve, or the C-guide. The height of the C-guides are always 7 millimeters. All of these C-guides are 7 millimeters tall. That's 6 millimeters to the stop plus 1 millimeter of guide structure down at the bottom to basically accommodate the stop. So a total of 7 millimeters in height. So going back to Blue Sky, now we have to look at our offset. All right, we can turn on the sleeve that we're designing, and this is the sleeve that we're designing. You can see that the outer diameter of the wall that will accommodate the sleeve is outlined in this orange box that we want on each side. We're seeing a cross section of that sleeve wall, if you will. The only dimension we have to be concerned with is this inner line right here. This line right here cannot touch the bone, because if it does, our sleeve will not seat into the guide. The rest of this will be calculated out of the way up to the limit of the STL file, which is the green line. But the sleeve has to stick through, and it has to go to whatever depth we've set it in order to accommodate our lengths. Okay. So what I'm going to begin to do is I want to change this offset so that the inner lines do not touch bone, and you can see it touches bone right there. So what I want to do is increase this offset. Let's just change it to, say, 9 millimeters. And Blue Sky gives you a warning that you're going off label. And now I can see that my sleeve doesn't touch the bone here. We should be good, but I want to spin all the way around this implant to make sure that it's in good shape. We can enlarge this view. I think I'm okay there. You could modify that. You'll see in a minute we may have to modify it anyway as we begin to plan this guide. Okay, so your stop position, if you'll remember, is 1 millimeter off of the bottom of where the sleeve touches. So if I want to calculate my drilling depth for any particular implant is going to be the length of the implant plus the length getting me up to this 1 millimeter position. Well, if I know that my offset, which is the top part of this line, is at 9 millimeters, and the stop is, because this sleeve is 7 millimeters tall, the stop is 6 millimeters down into the sleeve, then my drilling depth is the offset. Now the offset is, in Blue Sky, is defined as the distance from the top of the implant to the top of the printed surface of the guide, which is right here in the Versah system. Now, let me illustrate that for you. If I change the height of this abutment to 9 millimeters, you'll see that my abutment height, which starts at the implant, 9 millimeters, matches up with the top of the sleeve. Okay? So now, if I subtract off the 6 millimeters, that takes me to my stop position. So if I make the abutment now, instead of 9 millimeters, I make it 3 millimeters. Now this tells me exactly what my drilling length will be. And if I draw a measurement from that, from the edge here to the tip of the implant, you'll see that I'm at basically 13.5. Now, why is that? My abutment length, or to the drilling stop above the implant, is 3 millimeters. The implant is 10.5. That makes for 13.5 as my drilling depth. Okay, now, in the Versah system, you have a limited number of drilling depths that you can use. So let's go back over to their system and let's look at their drilling depths. I have a choice of either 13 or 11 or 15 millimeters of drilling depth. Okay, now, so if I go back to Blue Sky, if I shorten this back down by a 0.5 millimeter, I would probably touch bone there. I'll just show that to you. If I make this 8.5, and you could argue that that might be okay. I want to make this drilling depth as short as I possibly can. But I'm touching bone right there. Okay? So, because I don't want to drill actually into the sinus, I'm just going to position this implant just outside the sinus wall. And then we will bump it up from there. Now I can decrease this drilling depth down to 13 by decreasing the offset like we have done. I need to change this abutment length, since it is the abutment, the stop position is equal to the offset minus 6. So instead of 3, the stop position is now located at 2.5 millimeters. So now you'll see, if I take that measurement, I'm going to get a stop position of 13. This matches up with the Versah system and allows me to use a 13 millimeter stop in order to establish my drilling position. Now, word of warning: don't just go in and you, at the Versah system, grab a 13 millimeter stop and go all the way to depth. You have to learn the Versah system and how to drill incrementally down and make sure your osteotomy is in the center. There's a lot of nuances that we're not discussing in this video, but suffice it to say that this is how you set up a Versah guide to drill and osteotomy, to begin your osteotomy in Blue Sky. Now once you drill to this point and you have your osteotomy set, quite frankly, I like to switch over to, once I have my pilot drill completely done, I actually like to switch over to freehand and freehand the bump from there. I'll start at this position, insert my pilot drill into the osteotomy, and I'll take a measurement on the crest of bone where that crest touches the pilot drill. That becomes my short length. Let's say in this case the short length turned out to be, let's say the crest is here The short length turned out to be 9.5, somewhere between 9 and 10. Then I would drill to there. Now I would start to enlarge with the 2.0 and the 3.0 drill up to the 9.5 millimeter mark. After that, I would take the 3.0 drill and I would go as far as, say, 12 millimeters, which is 9 plus 3, into the sinus, and at that point you'll feel yourself drop in, or you'll feel it get softer to drill, but I would not go any more than 12 millimeters here into the sinus, or from the crest, 12 millimeters, which would be 3 millimeters into the sinus. At that point, I would then enlarge it to 4.0 at the 12 millimeter mark. Then I would begin to put my bone in to create the bump, and once I had, you know, a volume of bone that I needed for the implant, I would insert the implant, and then I would insert the implant down to full crestal distance, down to here. So this is how I would plan a surgical guide for a Versah bump using the C-guides. Okay, you know, at this point there's other, you have to design a surgical guide. I'll go ahead and do that real quick. If I get out of this, at this point this little ring you see has been planned to accommodate that C-guide. So now I just want to create a guide. I would go to the guide panel, draw a curve. We would draw this curve. I'll go ahead and clear this one just so you can see it being drawn again. We draw the curve by holding your shift key and clicking these points. And coming on around. And I can add some inspection windows. There's lots of other things I can do to this, but essentially, and I'll add one real quick right here. So these are the inspection windows that I had added for this case. It will cut this thing off flat at the back. It'll also create a window right here that I can make sure the guide is seating, and now you just tell it to create the surgical guide. Blue Sky will then eventually give you this file that you can work with. All right. You can label this. They have a label creator. Lots of different things you can do with it. But essentially, this is ready to be exported. You export this out of the Blue Sky software, and you pay an export fee for that. The software is completely free to use, but if you export something for production, then Blue Sky has a fee for that. This can be exported. You can load it onto your in-house printer, or you could send it to a printing lab. They can print it for you, have it back to you, and then you can do your surgery. Okay, I think that pretty much covers what we wanted to cover today, so I hope this helps, and we'll see you soon.